Dear colleagues, let me present you our report, Cognitive Modeling as a Tool for Strategic Planning of Industrial Development. The report was prepared by the staff of the Southern Federal University, Tatiana Makarina, Alina Kazanskaya, Yana Nalesnaya, and Svetlana Stash. This research is devoted to the need of the strategic plans formation for making forecasts of an economic development of Russia, namely the industrial complex. At present, the country's industrial complex has a lack of strategic development guidelines, and industrial production indices have not been growing over the past 5 years. One of the problems of this situation is the lack of long-term development plans and accordingly state forms of support. Strategic planning is an important aspect of strategic management in industry. This research presents the main trends in the Russian industry development and analyzes the tools of strategic planning. Strategic planning is a process that has inputs, actions, and results. Strategic planning uses a variety of tools and techniques. Such tools are expert method, socio-economical analysis, the balance method, engineering and economic calculations, the method of construction, economical and mathematical schemes, the methodology of synthesis and system analysis, and so on. It is important to suggest that strategies for different time horizons are important. Each of them has different goals and requires different approaches, different frequencies and participations. Thus, for development of the country's industries complex, it is possible to use the tools of strategic planning. Industry is one of the driving forces in the Russian economy development. Therefore, the study of institutional formations that contribute to the development of the country's industries is an important scientific and practical task. Figure 1 shows the dynamic of industrial production indices, labor productivity, physical volume of investments in fixed assets. The industrial production indexes has a constant dynamics of growth from 2015 to 2019 compared to 2011, and even in 2020, despite the pandemic, the labor productivity index is slightly more than 100%, doesn't have growth dynamics. The index of physical volume of investment in fixed assets has been declining in 2019-2020. The following macroeconomic indicators can also be considered. Internal expenditures on research and development in percent of GDP amount to 1.2% in Russia, and in 2018 1% to GDP, lower than comparable countries Germany, Denmark, USA, China. The share of internal costs for research and development in priority areas of science development, techniques and technology in the total volume of internal costs for research and development in the Russian Federation as a whole has grown only in medium tech types of economic activity and is 80%. In high tech type of economic activity, there is a decrease in this indicator in 2017-2018. The coefficient of inventive activity in the number of domestic patent applications for inventions field in Russia per 10,000 people is falling compared to 2015 and is 1.59 in 2019. In 2015 it was, for example, 2.0. The development of industry is characterized by the following factors: high rates of privatization processes as at best development neutral, preservation of the resource model of the Russian economy, low level of innovative activity of industrial enterprises, low degree of planning functionality and accordingly the problem of determining strategic guidelines and targets, failure to achieve the target indicators planned values. The above problems of the Russian industrial complex indicate that there is no long-term planning system that would contribute to systemic development. Strategic planning is vital to an industrial complex because it provides directions and targets, anticipates certain scenarios and plans the necessary actions to avoid them. Constantly changing technologies, industry trends, and global markets can challenge industrial enterprises. Many of today's leading industrial enterprises will not be able to remain leaders in the near future without a robust strategic planning processes. The toolkit for cognitive modeling of complex systems allows us to simulate the structure, state, and behavior of the latter to anticipate the development to make and justify the adoption of appropriate management decisions. There is a wealth of experience in the practical applications of this toolkit in various spheres and fields of activity. In theoretical terms, the main research is carried out in the following areas: the composition of cognitive modeling methods and methods for analyzing big data, scientific forecasting methods of system dynamics analysis and synthesis of cognitive models, structural analysis, composition of cognitive modeling with models and methods of decision-making, software development for cognitive modeling of complex systems, design of intelligent decision support system, expanding the scope of practical application of cognitive modeling tools, etc. The advantage of using cognitive modeling primarily include the ability to overcome the phenomenon of the social economic systems, presenting complexity for presentation and analysis. Whereas researchers such as Schwenk, Halabian, Porok, Eden, etc. have made numerous attempts to create universal tools for the cognitive support of managerial decisions making and forecasting process for solving strategic problems. However, practice shows that in such complex and diverse conditions in which modern enterprise operate, the creation of universal tools is futile and does not justify itself. However, Balatsky believes that what is needed is not universal tools, but some unified methodology that allows constructing cognitive models for specific systems for a specific period of time, taking into account the strategic visions of the stakeholders of these units. As noted by Garelova and others, the application of the cognitive modeling methodology in the context of industrial development forecasting at the regional level and at the level of the entire national economy is associated with a number of problems and contradictions of the science and practical nature. According to Krustelov and others, and Makarenko and others, the first weak point of the formalization of the arranged sign graph that underlies the cognitive map is the expert's subjective assessment group. Group assessment is preferable of the processes occurring in a complex dynamic system as well as the factors causing them. Moreover, the hierarchy and the placement of the weighting coefficients of the connection strengths between the model factors is also carried out by experts and therefore is subjective. Garelova and others note that the possibility of multivariance of the results of modeling such a system as an industry is obvious, which we face with when analyzing the accumulated research experience. Kim and Kazanskaya and others determine the possibility of checking the model by reverse verification through the introduction of statistical information from the past years as exogenous parameters, or one of the ways to solve this problem. However, it is also turns out to be very difficult since researchers are faced with the lack of complete, detailed, reliable and timely statistical information on the industry state. Companies, etc., points out that urgency, reliability, integration, lack of political pressure, continuity of methodological approaches in calculating indicators of different years are the main problem points of regional statistics. The third serious problem of the application of cognitive modeling of industry at the regional and state level is associated with the ambiguity of the indicator's choice as a consequence of the statistical parameters on the basis of which the quantitative values of the indicators to put in the nodes of the cognitive map are determined. A wide discussion in the scientific literature regarding the subjectivity of key decision-making in the process of a model building indicates that an infinite number of different cognitive maps describing the same objectively existing system is almost inevitable even within the framework of research projects with the participation of the same experts, but at different time periods and with different initial set modeling goals. Thus, considering the totality of this problem, the creation of a cognitive model of industrial development at the regional and state level, adequately perceived by the scientific community and the authorities responsible for the industry development in the country, is a difficult task that requires an integrated scientific solution. The authors propose to use a cognitive modeling tool to determine the vectors of development in the industrial complex. The first step in the formation of this kind of methodology is the development of a conceptual scheme of a cognitive management that is uniform for all its applications. At the same time, it is fundamental that the development of a conceptual scheme is such a complex problem environment cannot be done on the basis of traditional formal axiomatic approaches. More appropriate here, apparently, is the empirical approach widely used in knowledge-based technologies. Thank you very much for your attention.